We're live. Okay. So hi everyone. I'm Ben. I'm with Ivanica, and we're very excited to introduce Laurel Orr. Laurel is a researcher at Stanford with Ivanica, and we're very excited to introduce Laurel is a researcher at Stanford with Ivanica, and we're very excited. Oh God.
I can't hear anything. Okay, great.
All right. So what just happened was that we may have had the live stream open that we were testing. So that's a little bit of feedback. Anyways, well, all the professionalism completely out the window as is. I'm delighted to introduce Laurel Orr, who is a researcher at Number Station. Before that, she did her postdoc with Chris Ray and previously did her PhD at UW. And she's going to be talking about how to turn text into SQL queries and the benefits and dreams of this, and how also it's hard to realize often in practice. And with that, I will leave it to you, Laurel. Take it away.
Awesome, thanks. Let me go ahead and share. Oh, whoa, that's not what I expected. Share my screen. Can you guys see what do I see the actual screen? The slides or the
We do not see slides yet.
lovely. Well, I'm glad that worked out really. Oh, I know too. Okay. I can fix this. I want this one.
Yes.
Perfect. I think that's good.
Yeah.
Awesome. Okay. Awesome, everyone. Yeah. Thank you so much for the intro. And as I said, I work at a startup called Number Station. Joined there after my postdoc at Stanford. I'm going to be talking a lot about pretty much the lessons learned over the last year about really applying LLMs to the data stack. And in particular, we're going to be focusing on Text-to-SQL and kind of why people are really excited about it, but also really kind of how when rubber meets the road, it's really not all that. There's a lot of hype around what it is, and I want to kind of dig into what really the challenges are, and kind of some of the things that we do to overcome some of those issues. So I'm going to pause and give a little bit of a high-level recap of some of the kind of amazing things that we've seen language models do in the data space in particular. I'm kind of assuming everyone who's listening already knows what LLMs are, is familiar with them, and kind of some of the crazy tasks that they can do. And I all hope you'd use ChatGPT every day. By far, the best purchase I've made in the last probably decade of my life is a subscription to GPT-4. Anyway, so we've seen a lot of kind of explosion of work over the last couple of years, really applying LLMs to the data stack. And by that, I mean from the very start of kind of the standard kind of ETL pipeline, where it starts with data extraction. And we've seen work kind of pulling information from the web using LLMs, generating schemas, extracting structured data. So a lot of stuff kind of at the early stages of the data stack. We've also seen work apply kind of more in the middle of the stack, which is a lot of data cleaning and data wrangling. This includes simply like standard null value imputation or record matching, things that really help take data from a very raw, messy form after the extraction and turn it into something that's much cleaner and easier for users to interact with. Now, on the far other end of the stack, which we've also seen LLMs applied to, is purely in kind of the analytics phase and the data visualizations. When you think of Tableau, this is kind of where they live as well, and you've seen interfaces on top of Tableau as well. And so here, this is really serving business users who want to kind of gain insights from their data. And so here, there's a lot of work looking at chat interfaces and things to help users look at structured data, generate insights, and maybe even visualizations on top of that. So we've really seen language models being applied, to the entire data stack with varying degrees of success, which is overall been very exciting and invigorating. Now, the task I want to narrow in on for this talk is really this idea of text-to-SQL, right? And that's typically done at kind of the analytics phase of the data stack, so towards the business users side of the world. And just to make sure we're on the same page, I'm going to kind of quickly walk through what text-to-SQL is, although it's fairly self-explanatory. So this is actually a very classic database problem of natural language interfaces to data. I mean, I remember in my very first database conference, pre-deep learning really taking off, they were still trying to do natural language to SQL. So it's been a classic problem for many years, and a lot of excitement around trying to get it to work. And so how it starts is you basically have a user, typically a business user, who has a high-level question that they want to answer. Pretend, for the sake of this talk, we're going to have a schema, or pretend you have a data, which is basically orders. You have information on like maybe the state that the order was made, the priority or urgency of the order, when it was created, things like that. And this will be a working sort of schema that I'll use throughout the talk. So a user comes in, they ask a question like, how many orders do I have in each state? What under the hood, especially with LLMs, basically this question plus usually the database schema gets shoved at a language model, and it magically spits out the SQL query that you need to run, right? And so this at its core is the Text-to-SQL pipeline. It literally takes in text plus or minus metadata and spits out the SQL query. Now, typically the users who ask this, they don't actually know SQL or understand SQL. What they really want is the answer to their question. So very oftentimes there's a post-processing step, which is basically the SQL execution. It takes the SQL query, executes on the database, and returns the response to the user. So while this technically isn't the ML portion of Text-to-SQL, it's oftentimes, incorporated as part of that task. So here, the takeaway is you have business users asking questions over their data and getting answers, right? And why is this so exciting to people, right? There's something about this interface, which is a promise of what I'm calling self-service analytics, right? You now have business users who haven't built this pipeline that are potentially able to kind of gain insights and answer questions about their data, which again has kind of been this promise and this kind of dream of Text-to-SQL and business analytics for decades. And so here are a couple examples of these demos and prototypes that are coming out more on the open source side that are sort of hinting at this promise, right? So on the left-hand side, I'm sure you've all heard of it. This is like a LangChain screenshot that I found online, but using LangChain to go and ask questions on your data and kind of give you a summary of the answer. And on the right, there's another sort of open source package. And there's a ton of companies as well that are sort of looking at the space and showing these natural language interfaces on top of data and sort of doing sort of QA on top of it. And so this has just been this, again, there's a lot of excitement around the space because of this kind of self-service promise or inspiration. Now, it's worth pausing and really asking, which is going to be the entire rest of this talk, is this product really democratizing this ability to gain insights? Is it really this sort of self-service dream? And I can say with kind of a lot of confidence that no, at its core, it isn't, right? Like Text-to-SQL itself, I'd say is maybe an 80% solution. And here I'm not alone in this sort of understanding. These are kind of some recent postings I found on different blogs from kind of companies on the web. And on the left-hand side, you see, I think a blog post by Haystack, which actually was really interesting. So encourage folks to read it, where they're pretty much saying, hey, look, even after every prompting trick that you can try, you're never going to get, the dream of having this kind of business analyst asking questions without knowledge of the data is really not going to happen anytime soon. On the right, this is from a Hacker News post. They were also, talking about how like in product and reality, these models still fail. There isn't a lot of trust or confidence in the response, and they're, basically just not deployable. So we have this kind of vision and these prototypes, but they're really falling short when it comes to putting them into production and actually putting them in front of users. And so I'm now going to talk, especially from personal experience, about why this Text-to-SQL pipeline really isn't kind of text to insights or the self-service analytics that people really, really want. So the first challenge that you run into is what I'm calling user woes. And this is where the users who come at the systems and ask these questions don't actually know anything about the data or the schema. Like in typical enterprise pipelines, they're completely separate teams of people who build the data versus those who ask questions on the data. And so oftentimes the schema is ambiguous and these business terminologies it's not clear what the answer is. So for example, again, we're using this kind of orders data that I presented earlier. We have a user come on and say, hey, look, show me high priority orders from July of 2023. Now, from the user's perspective, that's a very unambiguous question. If they asked any of their colleagues what that answer was, that everyone, within their sphere would know exactly what they were talking about. But the model has no idea. The model only has information of the schema. And so high priority orders, if you look at this data, it's unclear what it means. Does it mean maybe urgent orders? Like maybe the flag is urgent is true, or maybe the priority itself equals urgent. It's unclear how those two are even related to each other. So it doesn't know what high priority orders is. If you also look at something as simple as from July of 2023, does that mean the created at date or the completed on date, right? There are these things that the model is never going to know the answer to. And so it's going to guess and possibly get the right answer, but it's not actually understanding the business terminology. And the challenge here is that the business users who are asking the questions, they don't even know the answer themselves, right? Typically, engineers will maybe build dashboards or separate pipelines to kind of help business users get answers to their questions. But again, the users don't know how the schema is built. So this is one of the first challenges that you run into immediately, is that there's just a very ambiguous understanding of what the right answer is when these questions are asked. So the next challenge that you run into is really just the core challenge of generating SQL. So for people who've built, done most generation tasks of these models, you realize very quickly that they're never going to be 100% accurate all the time. Right. And so especially when you come with fairly complicated questions like show me the year over year order purchase trends with grand totals, which actually is a very Excel style question where you add, maybe a row of grand totals at the bottom, is actually fairly complicated SQL queries that would probably involve unioning different, answers together and kind of trend lines and which is possible in SQL, but it's fairly advanced query. And even if you add all of the prompting tricks, and to be clear, every single trick will help performance, right? Everything makes the numbers go up, right? You can add demonstrations, you can add documentation retrieval with RAG, you could add these like re-ask upon error pipelines, scratchpad thinking, step-by-step, better schema, descriptions, right? Everything helps, but nothing is going to get you to cross that bar of making it accurate enough where you're in the 99%, 100% accuracy. And so at the end of the day, you have a pipeline that's just too brittle, and it's not gonna. Users are gonna have trust issues when the models are not always accurate. And the really critical thing with this, as I mentioned before, is business users can't fix the problem, right? This is the beauty of Copilot. If you guys have played with GitHub Copilot, is it makes mistakes all the time, but you know how to code and you can help fix it and kind of guide it to the right answer. Whereas with this, you have the users interacting with the system don't know SQL. And so even if you said like, hey, look, here's my best guess, they can't go and fix the question because they don't know SQL. So it really is a hard stop for business users to kind of ask questions when they just cannot fix the errors that the model spits out. Okay, so this is kind of another challenge related to both users not knowing SQL, but also just the fact that again, these models are not ever really going to be 100% accurate. So the last challenge is kind of this umbrella issue that you run into with privacy, right? And this has become a very real problem with the enterprises where they are very hesitant, if not unable, to use these third-party LLMs, which typically are the ones right now, although this gap is closing, that tend to do the best on some of these tasks, right? Again, give it a year or two, the open source, I firmly believe, will catch up, but we're not quite there yet for everything. And this is true even if the third-party model is hosted in a private VPC. A friend of mine works for a company who has their own private OpenAI instance, and their company still will not let them use it for certain tasks because they're afraid of what would happen if they transfer the data, even though it's in their private VPC. So there's even just sentiment of I cannot trust third-party owners of models, right? Enterprises really want kind of this left-hand side picture where users can ask questions on an enterprise-owned model, typically fine-tuned from a kind of an open source model that's been trained over the enterprise data. It's on their VPC, they own it, and they have complete control over it, right? This is what enterprises want that makes them feel safe, and there's no issues of sharing private or sensitive information. And so this is another issue which just makes deploying this even harder because in the open source, right, you now have to deal with training models and customizing them to kind of enterprise specific SQL. So given these three challenges, and there are more, which I'll touch on at the very end of the talk, I'm going to kind of talk about what we ended up doing at NumberStation and building our text-to-SQL pipeline. And I very purposely am going to put this in quotes because as I'll show throughout the next couple slides, it starts out looking like text-to-SQL, but really ends up not being text-to-SQL, although technically speaking, there is text and there is SQL somewhere. So like it's kind of text to SQL. You'll see where I'm going with it. So I'm going to start here with the kind of the high level diagram that I showed before, which is the text to SQL pipeline as I introduced it. And I'm slowly going to kind of modify it and add things to it as we kind of go through each of the challenges. And so again, right now we're starting out with the simple text in, SQL out that gets executed on the database. So the first and probably one of the most important things you have to do to sort of address the first challenge, which was user woes, where they're using business lingo, is you really have to rely and dig into and embrace semantic layers, right? Now, semantic layer is a common term for kind of a knowledge base of business terminologies and metrics and key phrases and basically business information. What that actually means under the hood is fairly vague, but at a high level, it's basically a curated knowledge base, knowledge understanding of how business users speak and how that relates to the data. So you can think of it almost as a middle layer between the data and the user that basically is serving as this translation between what the user says versus what they actually mean on the schema. And so, for example, if you have this, the database on the right, which is again this orders, and two example kind of snippets of semantic knowledge, I have represented on the left-hand side, kind of in a config style form, where maybe you now have a piece of semantics which says, hey, look, what I mean by urgent orders is specifically an order that is urgent or very urgent and requires attention within 30 days, right? And here there's actually a little calculation field which says how to map it to the SQL. So what you really care about is what the business terminology is and how that maps to the underlying schema. Similarly, you could have a date semantic piece of information, which talks about when orders are referenced, maybe by their creation date, so that when you're ever looking at filtering by orders, default to the creation on date as the one to look at, right? And this again is helping answer that question before, when the user says, show me priority work orders created in July. With these two pieces of semantic knowledge, you can actually understand what query to execute. Now, the huge challenge here is actually how do you get this information, right? So this is kind of, I'm going to be a little hand wavy here because it's still in very active development. But at a high level, this information is actually lying all over the place in an enterprise. Typically, they have a lot of SQL query logs, they have a lot of dashboards, they have a lot of company documentation. And if you're smart about how you mine and extract it, and again, LLMs can be helpful here too, you can actually start to automatically curate and build this semantic layer for users. And so the key thing here is now when the user comes in and asks a question, I'm not just directly feeding this to the language model with just data schema. There's actually going to be the semantic knowledge that comes in. Now, there are some things you have to do with kind of retrieval to kind of filter down the knowledge, but there's nothing super fancy there. The core thing here is that you're basically having this little mini translation layer that goes from the user's question down to the schema so that the model actually has a hope in understanding how to build this query and execute it. Okay, so we've introduced this notion of a semantic layer and how we're going to use this as a kind of core input to the pipeline. But now I'm going to talk about how we're actually going to be changing the outputs as well. So again, remember I had that notion of SQL woes, right? SQL can be fairly complicated. It gets hard to get it right. And so as a slightly more complicated query, pretend, for example, you had a database, which was, maybe there was joins over a couple different tables. Maybe they even have schema about how to do the joins. And when a user asks a question, the model now has to go and actually learn how to do the joins, figure out what columns to select, and address a slightly more complicated SQL query. And in reality, you get schemas that have 20 plus tables and thousands of columns, and it becomes a very tricky problem for the model to be able to kind of generate this SQL out of the box, just given kind of this complicated schema. And so what we actually do is we sort of realize that, like, hey, look, SQL itself is a kind of derived expression from what the user is talking about. So we don't actually need to output SQL to make this work. We actually instead, you can think of this almost as a kind of a DSL, like a custom kind of intermediate language, but we actually don't have the model output SQL. We have it almost output the semantics that the user is talking about, right? So every table, again, from a previous step, has a semantic layer now. It has understandings of what are the core business sort of units that really matter when users ask questions. And so we can actually have the model go and build a query for us in the semantic space that then goes and gets automatically compiled down to the SQL space. So for example, the model even says, hey, look, which assignees have the most urgent orders? It's easy for the model to be like, oh, I need assignees and I need urgent orders, and I see these things in the semantic space. And here's how these attributes I want you to build. And you can actually go and automatically generate the SQL for this, right? So you're now introducing, SQL compilers, but these are deterministic. And so all that the model has to do is, again, now interact with the semantic layer when it's generating queries. And one of the most subtle yet important pieces of this decision, which I am purposely highlighting in an obnoxious pink color, is that business users understand the semantics, which means if you're outputting in kind of user space, in the semantic space, they actually have a chance to give feedback and correct mistakes, right? So before, when you're outputting SQL and you had an error, or maybe you just got the wrong answer, the users had, couldn't fix it. Whereas now they can see, oh, like the model picked maybe this attribute, but really I was asking for this one instead. And this is actually a piece of feedback that you can act on. And so it's a way to slightly turn this into less of a zero-shot magic product and more into kind of a co-pilot-y style. It's not quite there, but like something that's actually more engaging and interactive to a user, which is very helpful because even in this space, the model is never 100% correct. So it really is important to build in methods and tools for users to give feedback on things. And so it's kind of, again, like a subtle, nice, very important side effect of outputting into this kind of higher level semantic space. So now our stack looks like this, right? So the user comes in asking questions. We, in essence, translate it back down to kind of, we have the semantic layer being coming in. Model actually still outputs this kind of intermediate semantic layer. And then all the post-processing is what's going to compile and execute the result, right? So we've now turned something that kind of was text-to-SQL into really not text-to-SQL, although, again, SQL is kind of a derived output of what actually happens. Okay, so the last challenge I mentioned before was this privatization, like the issue of using third-party models. And now that we've sort of decoupled this pipeline and really leaned on our ability to curate semantic knowledge and kind of simplified our output space, we can now actually go about and doing what I'm calling llamatization of the pipeline. Obviously, it doesn't have to be llama, but it's very common now to go and take things that did work for private models and turn them on with open source models through training. And very typically, that's a llama model because they tend to be some of the best ones and easiest ones to work with. And so now we go and work on this kind of model customization phase where we go and, again, turn on private models. But the real challenge here is actually how do you get training data, right? We've moved away from the text-to-SQL world and are now in this slightly different world. And so we have to understand how to curate training data for this customization. So this is still a very much ongoing research challenge that we're dealing with. And so as a first step, what we actually ended up doing was kind of simplifying the problem a bit and understanding basically how to just customize models for kind of a more nuanced SQL use case that we can kind of use in the semantic layer creation portion. And so this was actually a research project done with some amazing collaborators over at MotherDuck. For those of you in the database world, they do DuckDB, which is kind of this embedded alternative to SQLite that really focuses on analytical queries and have some really amazing syntax changes. One of my favorite that is that, in database world, every time you want to select something, you say like select star from table. And every time you're wasting like 9 keyboard strokes typing select star. And like one of the things they do is you can just drop that and just say like from table, right? It's, I don't know, like little tiny tweaks, but they do this all over the place. It's, anyway, I'm a pro DuckDB. I think they've done a really good job trying to make SQL more friendly. Anyway, so with these collaborators, our goal was to say, hey, look, let's understand how to kind of llammatize a model in a use case that doesn't have a lot of available training data, right? DuckDB is still fairly new. There isn't any existing benchmark or data set that outputs to DuckDB syntax. And so a lot of the challenge was how do we go and not only generate training data, but also make sure it's data that's incorporating the unique kind of syntax and functions that DuckDB has to offer. And so at a very high level, we have a blog post about this that that has more details, but we basically used a lot of open source models with some data cleaning pipelines to go and generate a bunch of training data for us from the DuckDB documentation and from existing text-to-SQL, some standard text-to-SQL kind of training data sets that are around. And so here the models were actually very good at helping us, as long as we guided them with kind of the right answer, at helping us generate questions and kind of flushed out SQL queries to kind of capture unique syntax of DuckDB. And so here's a couple questions. I have a couple examples of looking at some of this kind of DuckDB specific syntax. For example, at the top, they support an all keyword. So the model can kind of pick up that you can order by all, or you can also group by all. They actually support JSON editing. So you can see kind of some selection types with JSON on the middle row. And the very last one, which is very pandas inspired, I think, is they have a summarize keyword actually, where you summarize a data data set, which is not supported in any other SQL syntax. So a couple kind of examples of how you can actually kind of turn on a model for a slightly unusual task. And so in general, what we're doing is we go and slowly replace places that used the private model, in the semantic layer creation, in the text to kind of semantic layer output space, and anywhere else we kind of turn them into these open source Llama models that helps overall maintain quality, but then address that privacy issue as well. Okay, so at the end of the day, this is kind of our pseudo text-to-SQL pipeline, and just kind of overall looking at some performance numbers, kind of comparing traditional pipelines to this new sort of, in quotes, number station text-to-SQL pipeline. So here we're looking at kind of execution accuracy of how accurately we were able to capture the results given a user question. We have a couple benchmark data sets, the proprietary data sets with some customers, but you see overall that the purple bar is kind of this new text-to-SQL pipeline versus the green being kind of much more traditional text-to-SQL solution. And you see overall 10 plus points lift across the board, showing just that this using and leaning into the semantic layer from a business user and changing how the model does the output space really overall can help quality. And again, we're not at 100%, but my goal is not to be at 100%, right? My goal is to get very close to the answer so that with a couple pieces of feedback, a couple corrections from a user, they can actually get to the answer that they want, right? We're after we want to facilitate and make it a lot easier for the user. Again, it's very hard, even in this world, to be at 100% accuracy. So in the last couple of minutes, I'm going to talk a little bit about what are some of the challenges that I haven't talked about, and still some of the things that we're kind of actively working on and thinking about. So the first one is that it's actually a pretty interesting problem, is that even within the same enterprise, different users mean slightly different things, typically within a different group of a company, but different users mean different things when they ask questions. So if somebody says, how many P0 orders do I have? That could be something different from what another user means. Now, they're all very similar and very close, but you now have to have a model that kind of differentiates between users and groups. And things get a little tricky when you have, maybe things change over time. And so some users are actually unaware that maybe what they thought was the right answer isn't the right answer. And so you have to mix in this ability to have the model, be very customized to users while introducing some notions of auditing and making sure that actually we understand what the right answer is, because we really want to avoid sending wrong answers to users. And so there's just a lot of different different understandings and tricks here that you have to think through to make sure that you kind of get the customization that you want. Now, the last one, which I have personally been thinking a ton about recently, is that oftentimes users don't actually come with specific SQL questions, with things that could even be answered with SQL. They come with high-level goals of things they want to understand about their data and how they want to take action, right? So, for example, something like they would ask is, how can I optimize my order throughput, right? Which is a very reasonable business question to ask, but I don't even know how to answer that in SQL, right? Like that's a very high-level, complicated problem, and so you really have to introduce methodologies to let the user drill in a way that's actually actionable, and a way that you can get answers to those questions. And so there's kind of this idea of how do you allow for a little bit of open-ended exploration in a way that helps the user answer, achieve their goal in a way that's actually grounded in the data. So it's kind of a pretty interesting thing in some of the higher level questions that user ask that we want to support and feel like are an important part of the kind of analytics space. Okay, so kind of the overall takeaways from this talk is, in general, LLMs are still, really changing how we're interacting with data and the data stack. They have this intense promise of kind of the self-service nature, and you see a lot of prototypes that kind of feed into the self-service analytics. And I can say, deploying these things is really hard. We are nowhere close self-service analytics yet. But if you really think about the users and who you're building the product for and who can give you feedback, you can kind of start to make progress on how to make things, actually put into production in a way that's still benefiting users, even if it's not quite the dream that we're still a little far away from. Do not hesitate to reach out with questions. There's some blogs that explain a little bit more of the technical details if folks are curious. But I'll open the door to questions with however this podcast works. But thank you for letting me kind of field you about Text-to-SQL for a while.
Thanks so much, Laurel. Yes, and we have plenty of questions for you, so I think we can move into a sort of more conversational form.
Do you want me to stop sharing my screen, or what do people typically do here?
Whatever you like. It's up to you. I guess it's if you expect to refer.
It could be helpful to keep. I'm not screen would be nice. Yeah, there's a question on like some result
Okay, this is Miles' question. Yeah, so one student asks, are those proprietary dataset results, the bar chart shown, what was achieved after users read the intermediate representation and tweaked the queries or before?
This is before, yeah. So this is a one-shot style benchmark. Yeah. So it's just purely the first pass. But yeah, that's a good question. And actually getting evaluated. This is something else. I feel like been thinking about this for years. Like I feel like it was even around in the lab. Is that this notion of feedback is really important when you're building these LLM products and LLM, even like research projects. And our evals are still heavily focused on one jump, right? Like I give it an answer, can it answer it in one shot, which is still like a very important question to answer. But I actually think going forward, we're going to really need to advance how we evaluate these models in a more interactive fashion, right? Like maybe what you care about, like I feel like websites do this a lot with the number of clicks it takes to like start an AWS instance. It's not quite the same, but this idea of what we really care about is how fast the user can answer their question, not if they can do it in one hop. Like I'd much rather have higher quality with a couple of chats. But anyway, that's kind of a separate. I feel like that should be a third challenge that hasn't been addressed yet. So no, this was not with multiple steps, but is something that actually is very important to measure and hard to measure in evaluations. Because like users give a lot of different feedbacks, you don't really know what the next step is necessarily. I mean, there's things you can do, but it's important to get right and think about. That's a good question though.
So one question I have for you is, you've designed this semantic intermediate representation, and that it appears to very significantly improve performance. But then also there are some, queries that users have that don't even seem to map cleanly into SQL. And so my question is sort of based on your experience, like, is SQL really the right way for LLMs to be interacting with large amounts of data? Maybe we need different kinds of abstractions. Curious what your thoughts would be.
Yeah, I mean, at the end of the day, and this is actually something I did not appreciate. So I studied databases and when I was a PhD student and did not like them a lot, to be honest. And I appreciate them so much more now that I'm actually dealing with real customer data. I feel like at the end of the day, there's always like you have to at some point ground your responses on the data. So there has to be some ability to execute queries. Now, I don't necessarily think the model has to be the thing that determines what gets executed, but I don't think you're going to be able to completely decouple analytics and results from SQL queries. And I also don't think things where I mean, okay, maybe one day when we get to like millions of context length models, which I do think are in the future at some point, we could potentially feed entire data sets to a model and let it reason over it. But for now, we're still limited to, even though they're long context length, like we're still limited in space. So I don't think there's some work in like having the model perform the query on the table, and I don't think that's right either. So I guess to answer your question, I don't think you can ever completely decouple from SQL, but I agree that this intermediate language I feel like is a step in the right direction. I don't honestly think it's 100% what we want, but I don't know yet enough about what we do want, because you also have interesting challenges where enterprises want some control and auditing of the styles of analytics that the users want, right? They have users with different degrees of expertise and skill sets. And so they may not want something that's super, super open-ended because maybe that could lead down to maybe incorrect analysis or results. And so there's kind of this fine line between what the right framework is versus what something people can understand and validate. So no, overall, I don't. I think the most important takeaway is that you have to have the model engage in the same space that the user understands. So there is a lot of success, for example, in building like SQL Copilot tools, but they're built for people who know SQL, and so like that makes sense to me. Yeah, so I agree. I don't think SQL is the right intermediate space, but I'm not 100% convinced I know what the right answer is yet.
Do you want to ask one?
Yes.
Like we have Michael here. He's just coming.
Oh, hi, Michael.
Hi, how are you doing?
Good.
Yeah, so I had a question related to actually like some of this dealing with like intermediate language stuff. And so it seems like one advantage of going from LLM to intermediate language versus LLM to, let's say, SQL output is like this ability to deal with like hallucinations better, or like at least fail less gracefully, right? Like if you have a random comment like your JSON, like that can like kill you, but if you have it in like some, I don't know, description, like seems fine. Like, do you find that you still have to deal with hallucinations when you work with like this current like text-to-SQL pipeline, and like how do you best deal with them if you do?
Yeah, if anything, we almost have a problem with anti-hallucinations. So I found that if you, with the right with a little bit of the right prompt, and like we do again heavily rely on the right kinds of retrieval to pull in information. The model is pretty good at not kind of making up. I mean, it'll certainly sometimes miss the question, but it never just kind of completely goes off the rails and gives you something that makes absolutely no sense. If anything, a pipeline that we like to build is for, because like again, we want the semantic layer is not completely accurate or correct, and sometimes we want the model to actually give a little feedback and like what's missing. So the user is like, oh, like give me emergency orders, and we don't actually have any semantic piece of information. Like we'd like the model to guess what it thinks is the right thing here, and almost not hallucinate per se, but like give an educated guess as to what could be the answer. And sometimes it's actually a little bit hard, and the model tends to always rely on semantic information. So overall, like I haven't had a lot of issues with hallucinations, but it really relies also on having high quality inputs, right? Like the noisier your inputs are, the worse they are, the less sense they make, the more the model's going to kind of just go off the rails, right? So like, I mean, this is the classic problem of the last 20 years, but the quality of your data matters more than any single prompt is going to, right? Like you need it to be as clean and high quality as possible, to prevent kind of any form of model craziness.
Yeah.
Yeah.
Okay.
Yeah, one other random question that I was wondering about is like, so the value that you can provide to enterprises presumably changes based on like how often you get the answer right. And if you get it always right, there's a lot of value there. And if you never get it right, there's no value. But I'm curious what the kind of shape of that curve looks like in your view. Like, is there some inflection point where at 90% it becomes
Yeah.
massively valuable, or how does it look overall?
Yeah, so what we like to say is obviously at the beginning there's a warm-up phase where again like the companies oftentimes don't have or rarely have any form of semantic layer. They want one. Like it's very helpful to have this kind of codified business knowledge. But to start, it's oftentimes a little sparse. And so usually what happens is it's less useful at the beginning, because you have to have more and more users engage and kind of make manual efforts and tweaks, give us a lot of feedback. But over time, we actually will build up the semantic layer for a company, and get more feedback and more demonstration. So over time, what we want is to have it be more and more accurate and users having to make fewer and fewer edits, right? So like that's kind of the metrics that we care about. But it's never going to be where you just started things magically work. And so yeah, the idea is to have a curve over time where you start out with maybe a smaller group of trusted users who really know what's going on with the kinds of questions they want to ask, and you kind of slowly expand it over time. A lot of companies kind of have this onboarding warm-up process. Our goal is to have it in hopefully a lot faster than what can take years for some other existing kind of products in this space. Yeah, so that's kind of the curve that we would like to have.
So quick question on the semantic layer, Laurel. Why is it that you can't potentially like mine these from like previous queries that have been done and or documentation that's just like lying around the enterprise? Is it like, why does it necessitate that sort of like human feedback?
Yeah, so you can warm start or cold start. I always get confused if it's a warm or cold because like you're turning something cold to warm. And it doesn't matter. So you can always jumpstart the process. Is it cold? I don't know. I just kind of guess, and then people get confused, and then I always go off on this rant, and then people get more confused. Fine. So you can always jumpstart the process with those documentations. But the things is like, for example, with query logs, you understand what they want to ask, but you don't always understand how they're asking it. And so the model can oftentimes guess and do a pretty good job. But it's like oftentimes phrases, like the weirdest ones you see is where you have columns that are named like attribute A5, right? And really it means like the quality, the DMF quality score. Like I don't even know what that means, but and so it's things like that is very difficult to mine for unless it's either explicitly stated in documentation, which sometimes it's not. Like oftentimes it's just in their heads what the right answer is. Or you'll have it where like different engineers have different answers to the question. So a lot of it can be started with a documentation, but you always need a little bit of feedback, because of these orgs, like you have different people building pipelines and they do different things. And you also oftentimes find a lot of errors in their own data, where you actually have like different groups seeing different results, which they think are the same, but like they didn't even know it. So like it's just enterprise data is a lot messier, and not as codified as you'd like it to be. But yeah, you obviously start there from documentation and logs and stuff.
So speaking of the enterprise data, I have a bit of a research process question for you. Because I remember when I used to work on databases, getting good, clean enterprise workload database data was like one of the key problems inhibiting research.
Yeah.
I imagine that must still be the case to some degree. So I'm curious, given how data dependent AI is, how do you like think about this problem? Like, how do you actually do research in a productive way despite all the restrictions that are placed on the data?
Yeah, that's I mean, I think a lot about eval and process, like a lot, a lot. In that there's a very fine line between a data set that's clean enough for you to make progress, but doesn't give you false positives about the quality. And so what you oftentimes do is before we do anything is you sit down and you understand like, hey, like what do I want this to behave like? And let's get a small data set that even if I have to manually create it and work with our customers to make sure it's like correct, we can, send them, be like, hey, look, does this make sense to you? And make sure you have, even if it's like a tiny, tiny test set, but you always have to start grounding it in numbers and quality numbers and making sure you have almost like a contract signed through data as to the inputs, outputs that you want to capture. And then ideally you always I always sort of start out with like simple data sets, the cleaner things that you have, typically built manually over time, test cases. But the very end, like you need to show on, customer data is messy and you have to also have the robustness there. So a lot of it is kind of up, starting out simple and clean to understand the insights, but then at the end of the day, testing on the real problems, right? Very similar almost like to academic research, right? Like you start clean with insights and good abstractions, and you test on the real thing and realize where your assumptions fail or not fail. But the biggest thing is always just to continually be evolving also your evaluation sets and how you making sure that they stay up to date with as you get different kinds of data and challenges coming from different customers. But yeah, it involves a lot of manual effort and a lot of spending time making sure your data is clean, but it's every time it's worth it, right? Yeah, if somebody says I want to spend a day cleaning up data and generating eval set, like that's always a good thing just to spend time on.
And
I wish there was a nicer answer, but I don't know if we're ever. Maybe one day. I mean, I've heard of some companies, coming up that are working at like helping automatically generate kind of eval sets for things. So we'll see what happens. It would be great if we could get that semi more automatic. I think there's things you could do actually, but you always have to have some manual verification, I would assume.
synthetic data. Lots of people excited about that.
Wait, what did you say, Michael? Sorry.
Saying like synthetic data, lots of people excited about that.
Yeah. Yeah.
Yeah, that's an interesting question. Like, do you think so right now, like people are sort of like using synthetic data to help with, let's say, getting LLMs to be better reasoners or like do better on like math data set or whatever. Like, do you think like these kinds of things are for like productive for, I guess, like these kinds of like, I don't know, SQL kinds of text modalities in some way? In some ways they could even be like more productive because you are dealing with like some kind of like set structure. But I'm curious like to hear your thoughts on that. Like,
yeah, I love synthetic data. I'm fascinated by how to generate it correctly. The things, yeah, I mean, I think it's going to be well, I don't even know if I won't even use the word synthetic because when I think of the word synthetic, I think about like templates. Like here, I am like a Python deterministic function with a random seed that like generates data for you. I think it's much more LLM generated data is kind of where we're going to go because it has the randomness and the kind of natural generation capabilities where it doesn't quite like it. You overcome a lot of the issues with purely synthetic data where like the diversity is dependent on your ability to construct diverse templates, which is very hard to do because it's just death by 1,000 cuts edge cases, whereas models actually have a better time doing it. So I 100% believe we're going to get in places where I would love to be where 95% of the data is generated with language models, right? Different kinds of models too. It doesn't have to be one, both training and eval. I think you're always going to need some manual effort to make sure that it's matching the same distribution that you're seeing in the real world, and that certain nuances of the data, the problem states are captured. But I absolutely think it's going to be the future. Where we're going to get like notions of even like generational models, where like one model was trained on this other model's data, which was trained on this other model, like parents of the models and children models, and anyway, it's a kind of cute idea, but yeah. I mean, I think the thing that you have to be really careful of, which I haven't, with some things about SQL make it a little easier, is how do you clean the data afterwards, right? Because the model is going to generate sometimes it's like a little inaccurate, it misses things. And so you have to have some ability to type check. SQL is really nice for that because you can always check if it's like a correct SQL expression. So you can kind of ground it in the grammar. But it still fails sometimes when you just have like the instructions bad. So there's a lot of work in the cleaning side, which I think SQL helps with a little bit, but is going to be true of any synthetic generation process. Yeah, but I think it's worth investing in for sure. It'll open up a lot of doors if you can figure it out.
Yeah, that makes sense. I guess also kind of related to the notion of, let's say, LLMs in the loop. We have an audience question related to this notion. I guess on another side of things, it's like, okay, like you can imagine that like you want to tackle like this kind of problem with like purely LLMs, or you could also use, let's say, prior like rule-based or I guess rule-based approaches
for the DSL.
For the DSL, like yeah, like formal semantics, or I can even imagine just like when dealing in general with like this stuff, right? Like I don't know, macros or what people had used in the olden days before copilots or whatever.
Yeah, yeah.
Like, are you bullish on like this notion of like just LLMs or like LLMs plus rule-based approaches? Like, what are your thoughts here?
Yeah, I generally like to encourage. I mean, it really depends on the problem. Ultimately, like it's a lot easier to build a product that's actually less reliant on LLMs, right? Like you get deterministic workflows are amazing, and very nice. A lot faster, a lot less issues. So like the more you can rely on heuristics, the better. Oftentimes though, LLMs help you go a lot faster to start, right? So if anything, sometimes it's nice to start playing with an LLM and seeing what's possible, and then understanding what pieces you can peel away with kind of deterministic code if you can. There are some things like entity resolution. It's not on the slide, but like it's like Monica knows all about it, right? Like you fuzzily match records. That's actually a great use case where a little fuzziness from the model plus a lot of rules is actually like a really great situation because engineers can understand rules. They like to type check them. They're a lot faster, and the model can kind of handle the edge cases. So it's kind of, I feel like the dream scenario is it's almost this like head versus tail argument. Like you'd love to handle popular things with rules and caches because like you don't need logic. They're like very common patterns you should just know, and the models are very good at the kind of the fuzzier edge cases that maybe are really hard to capture with rules. So in my mind, that's kind of where the right balance is, but sometimes it can take a long time to get there. And with some of this generation stuff, it's a little, I feel like deterministic text-to-SQL was really never worked that well at all, so it's a little hard to build off of something that kind of just wasn't that viable to begin with. But anyway, so I think overall I'm not a 100% LLM kind of person. Especially for these kinds of tasks, like rely on heuristics as much as you can, right? It makes your life a lot easier when you're actually building these things.
Yeah, that makes a lot of sense.
So one more student question coming in is one problem with enterprise database management is that oftentimes there are lots of different databases and you don't have the master data management working properly. So then you have a bunch of duplicate or nearly identical columns. And so the student is asking, can your DSL sort of help aid the master data management and like detect these overlaps and whatnot?
Yeah, actually that's so ironic because this is literally a challenge we've been dealing with like the last 3 weeks. Enterprise data is a disaster, right? It's a mess. And you'll have like they have like 5 tables they want to join that like is literally just like different filters applied to the same columns. So a lot of it is, the thing is like you have to understand sometimes who you're building the tool for. And so at the moment, you first have to understand how you want to solve the problem. Ideally, you would solve it as upstream as possible. Like you would love it if companies came to you with these really clean, beautiful data sets and like we want to get there. But kind of they're almost separate teams, right? So you're only talking to this team. You can't go and be like, well, make this team fix the problem because that's gonna be like a 6-month iteration cycle. So a lot of it is how do you address the problem right now in the product. And so a lot of it's like what can you do to clean and understand what the duplicates are, and then think about how you can actually build that out long term, because we'd love to get we want to move up the stack as much as possible to get to the point where we can help control the schema and clean it, right? Because the more you own, the cleaner and kind of seamless things can be. It's very hard when you're kind of wedging into one pipeline because there's noise everywhere else that you can't control. So a lot of it's like how you build that in and then understand how you want to work towards a longer term solution in that space. But yeah, no, it's very messy. Duplication is a huge problem. But luckily they're not, especially when you're in the semantic space, it's catchable, right? Because like you understand like, oh, these things are all saying exactly the same thing, like maybe these are the same. Yeah, and you oftentimes realize that customers don't always understand their own data. So like you'll have different queries and you'll ask them, like, so some of it's also understanding what they know and don't know. It can be kind of a tricky balance as well to work with people who have different expertise of their own underlying data. But yeah, that's a good question. Yes, we'd like to get there. Yeah, a lot of root problems come from bad, poorly designed schemas, which was like the first lecture you ever have in databases is like normal form. And you take the lecture and you're like, why is this important? And then like a decade later, you're like, oh, this is really important. Good to know. Sorry. Yeah. It was like the second lecture in databases with like normal forms. And I was like, I don't understand why this matters, but okay, cool. Learn decomposition algorithms. Yeah.
One question I have for you about kind of the broader problem and the economics of it is, where do you see a text-to-SQL really unlocking value? Is it helping, large enterprises get more insights, lower costs? Is it helping smaller, small businesses work with data that they wouldn't otherwise be able to work with? How do you break it down? How do you think about it?
Yeah. So I mean, I think in my way, there's like two big like forces right now. There's like this text analytics, which is kind of what we're trying to do right now, which again is moving a little away from SQL. It's using SQL as a derivative, not really the output. I do think there's a ton of value in SQL specific copilots, right? Like if you've looked at enterprise SQL queries, they are these 800-line behemoths of SQL functions that have been written by 5 different people with things are commented and dedupe, like they're messy. And getting models to help I think automatically like simplify some of the code, just simple like summarization descriptions, helping them generate it. A huge problem is SQL efficiency. People will write really inefficient SQL. And I think there are things models can do in that space to help make things more efficient. So I think there's very valuable tools that can be built that literally help people generate SQL better. I don't think you're going to get into a world where they generate SQL automatically, but I do think like SQL copilots, like specialized copilots for SQL that understand the semantics and the data, have to have special parsing involved, right? Like I think those can provide huge value. And I do think there's stuff to build, obviously, in the kind of analytics space, which is helping in the more data insights. But again, that looks less like text to SQL. I do also think there's some really interesting things you could build when you decouple the task knowledge from the execution layer. And by that, I mean like oftentimes SQL is literally just a method to building some data transformation pipeline. It doesn't actually have to be in SQL, it can be written in any language that works. But there's a core amount of logic there. So this idea of an intermediate language, I think, is actually a really fascinating kind of almost like a compiler stack you could build where you have you have a whole bunch of models that help do text to like task. And then the task is compiled down to whatever language works best, right? Like maybe you really want Rust. Like, I don't know. People love Rust. So I think that's like really fascinating, right? Or even like you're talking about CUDA kernels. Like this is like I really thought of this idea right now. But like in essence, when you're building it, you probably have a lot of things you want to do. Like you have instructions in your head of what you want to build. Like wouldn't it be amazing if you had like a DSL for CUDA kernels, right? Where the model helped you generate this intermediate language and they compiled it all down to CUDA for you, right? Like it's like I feel like there's a very big vision there of like a totally different way we can interacting with code, but I haven't thought more about this kind of high level dream of like these different kind of intermediate languages being compiled down and really abstracting the skill of coding versus the logic of coding, which are independent processes almost.
Cool.
Yeah.
You anyone? Or else
Yeah, time. Do we go to 1:30 or 1:20?
We technically go to 2:50, but
2:50.
But I mean, if there's no more questions from students, and I'm all out, like I would no need to. So cool. Monica, you have anything else?
No, I think the last question I just had is, like people think, as these models improve, kind of a lot of these gaps where we necessitate these like hand engineered solutions are kind of gonna go away. Like, how do you see that playing out here? Like does the stack that you guys have kind of like in the pipeline that you guys have written out, do you see parts of that being replaced, or like even if you do have like these improved capabilities, like you still have this like fixed pipeline?
Wait, so you mean like a tradition, like so traditional pipelines as if are those ones that can be
or kind of like what you
replaced,
already
or
have right now? Like say GPT
right.
7.5 comes out, like what changes, if anything?
Oh, I see. Yeah. Um, That's actually a really good question. I mean, yes, I can't imagine things won't change. I mean, I'd like them to change. Why not? It's exciting. I think at the core, there's probably gonna be a wave where like you get like in essence, what I would like is to move. Like my hunch is what's gonna happen is you're gonna be able to move to more upstream sources of information, right? Like the things that I feel like size and iterations of GPT gives you is like better ability to do tasks, but like a lot more robustness to noise. And so my hope is that over time you get to the point where like the data that you clean matters less. Like that, if you think about something for me that would break open machine learning, it's the fact that like I would love it if it was garbage in, not as garbage out, right? I don't know if we'll ever get there. Like that's the paradigm we've been living in, garbage in, garbage out, which is true, and it's still true with these models. But like, what if we could live in a world where it wasn't quite that way? Like I feel like that would break open a ton because all of these data pipelines that we still have to fight with would maybe not matter as much. So I think that would be really amazing. And I do think also with like some of the work, my hunch is GPT 7.5 is going to have this incredibly long context length, I hope. And a lot of the challenges around training, I think, will go away. Like there is a world, I don't know, probably not. Like I think you're always going to have some advantage to training smaller models, but I could imagine a world where there are some models that you may never need to train because, like in essence, you're training in the context, right? Again, this is like very, very future thinking. So I can imagine the whole like private, like modularizing models and training them may not matter as much when you can, in essence, just train in the context. Again, far away from that. But so that's what I'd like to see is like upstream parts of the task space get eaten up, training goes away. But I still think there's going to be always some amount of customization and tooling, and user interfaces are never going to go away. And that matters a lot, which is how users get feedback and how they engage with the product. So like those things I think are going to be there for a long time. But that's where I'd like to see. I think there's some interesting stuff in the multimodality space of the world that could be fun. But that's a little bit more like on the data ingestion side, where you kind of get a bunch of these like multimodal kind of styles of inputs, right? Like PDF documents, pictures, images, videos, where more curation on that side would be good as well. So yeah, so I think a lot of the pipeline could be blown up. I don't think it'll 100% go away. Where I don't think an enterprise will just be able to 100% plug in, use GPT 7.5 and things will magically work. But the hope is it gets easier.
Awesome. Thank you.
All right. Thank you so much, Laurel. This has been great. I'm gonna turn off the live stream. Give me 1 second.
Yeah, thanks.
Okay, I think